Here's the fastest way to lock in Fraunhofer single slit and double slit diffraction for your exam. Fraunhofer just means far field, source, and screen effectively at infinity. In labs, I make that happen with lenses so the incident wavefront is plane, and the diffracted light is focused onto a screen. Single slit first. Imagine the slit as tons of tiny sources, Huygens principle. They all interfere with each other. The result? A big bright central maximum, then dimmer fringes that fade fast. The darks, minima, happen when a synth, Mester NL, where A is slit width. That's the go-to condition. Brights between those are weaker and sit roughly at a synth, Nesun+1 serial 2. On a screen at focal length f, the central bright width is 2 filter A, so larger L, wider central bright, narrower slit, smaller A, wider pattern. Make a bigger. Angles shrink. Fringes pack in near the center. Intensity follows I0 sin V2, with V shears PA synth L. That's your envelope shape, now double slit. You still get that same single slit envelope from each slit, but on top of it, you stack tight, evenly spaced interference fringes. Interference maxima follow D, synth nature MLA, where D is slit separation. Here's the plot twist. If an interference bright lands where the single slit envelope has a dark, a synth national, that order goes missing. Classic exam point. Missing orders. Quick compare you can recite under pressure. Center, both bright. Single slit, first dark at a synth, JRL, MR1. Double slit would have a bright at that same angle if not killed by the single slit minimum. Spacing. Double slit fringes are uniformly spaced by D. Single slit fringes spread by A and fade fast. On-screen scale at the focal plane, XFT, so swap synth XF into the formulas to get positions. One last memory hook. Envelope by A, cone by D. A sets the big shape, D sets the fine stripes. Nail those, plug in L, and you're golden.